You ever wonder what's really going on when a baseball flies through the air? Or what keeps the planets from just, flying off into space? Well, it turns out there's a kind of invisible rulebook for everything that moves. A rulebook written over 300 years ago. So let's get into it. We're talking about Newton's 3 laws of motion. All right, so let's start with something we've all seen, right? You kick a soccer ball. It rolls, and then it just stops. But why does it stop? Why doesn't it just keep on rolling forever? The answer to that question? Well, that's the key to unlocking Newton's very first law. So that first law, it's all about this idea called inertia. And honestly, the best way to think about it is to call it the law of laziness. Now, of course, objects aren't actually lazy, but they kind of act like it. They have this built-in resistance to changing whatever it is they're already doing.
Okay, so here's the official wording. It sounds a little dense, right? But what it really boils down to is this. Things just want to keep doing what they're already doing. Simple as that. A book on your desk, it's going to stay put. A satellite that's zipping through the vacuum of space, it's going to keep zipping in a straight line forever unless something else messes with it.
And that brings us right back to our soccer ball. See, if we lived in some kind of perfect, friction-free world, no air, no grass, slowing it down, that ball you kicked, it would literally roll forever. Seriously, it would just stay in motion, coasting along at the exact same speed, just like the law says it should.
So, okay, why does it stop in the real world? The answer is in that last part of the rule. Unbalanced forces. You've got the friction from the grass and the air itself pushing back on the ball. Those forces are working against its motion, and there's nothing pushing it forward to cancel them out. They're unbalanced. And that imbalance is exactly what grinds the ball to a halt.
All right, so if the first law is about how things resist change, the second law is all about how you actually make them change. This is where we get to the really good stuff, the link between force, mass, and acceleration.
And at its core, the second law is something you already know, deep down. It's super intuitive. It's just this. It takes more force to move more stuff. The more stuff, or what physicists call mass, an object has, the harder you have to push or pull it to make it speed up or slow down.
Just think about a shopping cart, right? When it's empty, it's got low mass. A little nudge and whoosh, it takes off. But what about when it's totally loaded up with groceries? It has way more mass. You've got to put your back into it, push with a lot more force just to get it moving.
And this whole idea, this relationship, it gets wrapped up perfectly in one of the most famous equations in all of science, F equals ma. Force equals mass times acceleration. It's like the perfect little recipe for making something move. It tells you exactly how much push you need for how much stuff.
Okay, let's move on to the third and final law. And this one's a bit of a twist. It's not just about one object. It's about the interaction between two objects. The big idea here is that the universe always pushes back. Forces never, ever happen alone.
I'm sure you've heard this one before, right? For every action, there is an equal and opposite reaction. It's this beautiful, fundamental symmetry in how the universe works. You literally cannot touch something without it touching you back. You can't push on anything without it pushing back on you with the exact same amount of force.
Let's take a huge example, a rocket launch. To get off the ground, a rocket's engines blast super hot gas straight down with incredible force. That massive push on the gas, that's the action. And here's the magic. All of that gas being pushed down is also pushing the rocket up. That's the reaction, an equal and opposite force that is so powerful, it lifts this massive machine right into space. The rocket is literally pushing the planet away to fly. But hey, you don't need a rocket to see this in action. Just lean against the wall. Go ahead. The push you're putting on the wall, that's the action. And that solid feeling of the wall pressing back on your hand? Yep, that's the wall's equal and opposite reaction. It's the exact same principle that lets a bird fly by pushing air down or lets you swim by pushing water back. So there you have it, the big three: inertia, force, and action-reaction. But why do they matter so much? Because these aren't just some old, dusty rules in a physics textbook. You can think of them as the operating system for our entire physical world. They're running in the background all the time. Just look at how far-reaching these are. They're behind rocket launches and space travel. They're why car safety features like airbags and crumple zones work. They're all about managing forces and inertia. We use them to build bridges and skyscrapers that don't fall down. Anytime you play a sport, kick a ball, swing a bat, you are using Newton's laws whether you know it or not.
And on the grandest scale, these are the exact laws that allow us to predict the orbits of planets. It's just incredible. And really, that's the biggest deal of all. Before Newton, the universe felt, well, kind of random, almost magical. But after he laid out these laws, we started to see it as a huge, complex, but ultimately predictable machine. He didn't just discover some rules, he gave us the rule book to the whole universe.
So think about it. These 3 simple laws describe the motion of everything, from a single grain of sand all the way up to a spinning galaxy. That is an absolutely mind-blowing idea. And it kind of makes you wonder, right? If these are the invisible laws that govern all physical motion, what are the invisible laws or principles that govern the motion of your own life?